Okay, in this final tapes, Be'ez Hashem, this is the last part of the Rambam. This is the last section. We discuss a few final loose ends, and this will entail. I'll just give you an introduction. We will find out the altitude of the moon. It means how many degrees it's above the horizon. The Rambam talks about that. Also, the horns of the moon, where the anhayinite, the Rambam learns Pshat in the Mishnah. So when you go outside, you see the moon and it's beginning of the month, and you see the moon is almost about to set. So you can see that the moon has two horns. They're pointing towards a certain direction. They're pointing sideways or north or south or exactly which direction they're pointing. We'll figure that out also. And so there can be exactly definition. We'll get into what it means pointing and how we figure that out. Just giving you an outline. And then we will also calculate the um, we'll also give you calculate how many degrees is from the moon to the sun. We didn't do that yet. Interesting. The Rambam doesn't talk about it, but it's just curiosity. If you draw a great circle from the sun to the moon, it's obviously not the same because the moon could be 5 degrees above the ecliptic, so it's a little bit more. Let's say the moon on the sun is the Urch from the moon is 20 and the Urch of the sun is 10. So it doesn't mean it's 10 degrees apart because there is in the sky the moon is 5 degrees above the ecliptic. So that means if you draw a line from the moon to the sun, it's a little bit more. It's like a diagonal line. It's more than 10 degrees. So we'll talk about that also. And we'll also discuss the thing that we discussed already, but we want to discuss it again. This has to do with netiyas milkeh. Now, I want to start with what I finished now. Netiyas milkeh. Look at this picture here. So this picture we went through many times already. We'll go through again. CB is the horizon. AC is the Galgal Hamazalis, that's set. And AB is the Kava Majve, that sets. We made an example. AC is, let's say, Tele set. At the same time, AB is from the celestial equator, also a portion of set. We did that many times. We figured it out. It comes out to 35. And this is 30. This is 35. Let's remember that this big angle A here is 23.5 because this is the angle that the ecliptic with the mashve create. And also we know that the angle B is 58 in Eretz Yisrael because this is the celestial equator where the horizon create an angle of 58. This has to do, since Eretz Yisrael is 32, so the angle that's created to the celestial equator and the horizon is 58. That's always the same. You can see that very clearly if you have a celestial globe. You set it for Eretz Yisrael, and you'll see that the celestial equator creates an angle of 58 with the horizon. So we know the angle B, we know the angle A. This is 58, this is 23.5. And AC is also given because it's given 30. And then we found out AB. We did the math, we had a formula for that. But you know the rule already. If you know 3 angles, you can find the rest. Now we want to find this angle here, netiyas milkeh. Netiyas milkeh means, imagine you're extending this angle a little bit more. This AC line is going a little bit higher up. So you have here the ecliptic, you have the horizon. We want to know what angle does the ecliptic make with the horizon. This angle here. So we'll show a little bit clearer the pictures. We'll scroll down here. I guess you can see. Let's go to other pictures here, clearer. Okay, here we go. Oh, this is a very clear picture. This shows, this is the Galgal Amazonas. This is the celestial equator, and this is where Talat's at 30 degrees, and this is 35. And you know this is 23 and a half. This is 58. You want to know this angle here on top. It's obviously 180 minus this. So if you know this, you automatically know this. And by the way, just good to mention that by the sine function, the sine of 89 is the same like the sine of 91. So when the calculator returns the inverse sine, it can be either 91 or 89. Just curious. So that always the return will always be the less than 90 if you have an inverse sine. Okay, now this one here shows for Meznaim. This is again the Kav Mashra Shemaimi. This is Meznaim. It shows Meznaim as set. And it shows that in a short time, Meznaim, a big part of Meznaim have set. So here's the other way around, that the celestial equator sets slower than the and again here we want to know that the celestial equator sets slower than the ecliptic. And again, we want to know the inclination of the ecliptic towards the horizon. That is here hidden. Can't see it so well. It's on the side, totally on the right side. It's a very low inclination. Oh, here we see it on a picture, very clear. This is the Mashve, this is the Mazalas, this is Talat, 23, 58. We all know netiyas milkeh, this angle here. Very clear. So the formula for this is also quite simple. The formula works like this. You take the since we know already the C, this C we figured out. It was quite complicated, I must say, but we figured it out. If you remember, we did this whole manipulation. We figured out what C was. We did it numerous examples to figure out C. If you know the mazals, you know this is 30, you can find C. So after finding C, it's quite simple. Why? Because then we have, it's called the sine formula. It means like this. You'd say the sine of this angle is called big C over sine of lowercase c is equal to sine 58 over sine B, or sine Mazalis. This is called the sine formula, that we can make it any big ones over the small ones are proportional. I'll repeat again. We want to solve this angle here, sine C. And then automatically we'll know this one. So let's first solve this angle. We don't even have to worry because the calculator will anyway return the small angle, not the big one. So once we solve for this, the inverse will get the this angle here, the small one. But anyway, we do like this. Sine big C. I'll repeat again the formula. Sine big C divided by sine small c is equal, yeah, this is proportion. The sine big C over sine small c is equal to sine 58 over sine mazolas. Let me try to type it here. Oh, sine, I think I can type it. Sine, making capital C divided by sine small c is equals, this is in proportion to sine 58 divided by sine 30. Or, so we can rewrite this as sine c is equal to, you just flip, make sine 58 times sine c, sine 58 times sine c divided by sine 30. This is a very compact formula, and you can use this for any, and then you just find the c by doing in a calculator. You put the inverse of sine, it's called the inverse sine to solve a c. So again, the steps are like this. You find first sine c. That's through our old method. You find what this angle is, how much is from the Mashevet set. Then you multiply it by sine 58, you divide it by sine 30. So it's not 30, it's the sine of the ecliptic that have set. It can be 30, it can be 40, it can be 50. The formula works for anything. And then the answer that you get, you just take the inverse of that. That's going to be C. That's going to be this angle, netiyas milkeh. So I'm writing C is netiyas milkeh. That's it. That's the netiyas milkeh. Inclination of go mazolas towards horizon. Okay, this is how this thing works. I don't want to make this bigger. So this is what we did in this tape. We just solved. Now we'll use it soon. It's an important function. It's important to know this, but it's quite easy. Once you know C, you just use this formula, sine. Oh my goodness, I don't know how to. Okay, I guess I just have to say it again by heart. It's sine of big C is equal to sine 58 times sine C over sine Mazalis.